Hi everyone, in this question we are going to review rational functions. So I have a function r of x equal to 3x squared minus 2x minus 1, that's the numerator, and x squared minus 1 is the denominator. The first thing we're going to do is factor both the numerator and the denominator. So here I have 3x squared minus 2x minus 1. And in this case, what I could do is just basically factor by trial and error. I'm trying to find two factors that would multiply to this. And because of the coefficient of x squared not equal to 1, it's going to be a little bit harder to factor, but there is really not that many choices here because this should be 3x and this should be x because that's the only way you can get 3x squared. And then this is negative 1, so that's just going to be either minus 1 plus 1 over here or the other way around. Let's see if we can FOIL it and see it is 3x squared plus 3x minus x. Well, that would be plus 2x, so I guess this would be a plus, and then that should be a minus. Now, another thing you can do if you have a calculator and let's say you do not know how to factor, what you could do is try to find the zeros using the quadratic formula. So let's just say that a is 3, b is negative 2, c is negative 1. Now, computing the discriminant is b squared minus 4ac, and then your roots are negative b plus square root of the discriminant divided by 2a, and then the other one is negative b minus square root of d divided by 2a. Now this one you can convert to a fraction. So I can see that there is 1, and x equals 1 will correspond to x minus 1 being a factor, because if you set x minus 1 equals 0, then you would get x equals 1. So it's like the opposite. So you want, if you see the root of x equals 1, then in the corresponding factoring, it would be x minus 1, not x plus 1. And then the other root that you see here using the quadratic formula is negative 1/3. So first of all, that would correspond to x plus 1/3 equals 0, right? So it should be x plus 1/3. And then if you just move this 3 over here in front of x, you would get 3x plus 1 equals 0. So the 3x plus 1 is the factor. So it's called like a bottoms up thing where you take the number on the bottom and move it as a coefficient of x. And you can see that if you were to solve 3x plus 1 equals 0, you would subtract 1 from both sides, right? And then you would get 3x equals negative 1, and then you divide by 3, and that's how you get the negative 1/3. So negative 1/3 will correspond to 3x plus 1. So that actually can also help you factor if you're having a problem with it. Okay, so let's just see that this is going to be 3x plus 1, x minus 1. Now this one is actually, you don't need any quadratic formula. This is difference of squares. So you should already have that memorized. When you have something like a squared minus b squared, that factors as a minus b, a plus b. And in my case, I got x squared minus 1, which you can think of 1 squared, which is x minus 1, x plus 1. Now, if for some reason, again, you are like, well, I don't remember how to factor it. In this case, for x squared minus 1, we can see that a equals 1, there is no x, so b will be 0, and c will be negative 1. And then you can see that your answers are 1 and minus 1, which correspond to x minus 1, x plus 1. Okay, so that, whether you're using quadratic formula, you know how to factor, we got that. Okay, so now that we factored both the top and the bottom, we're going to start looking for the asymptotes, vertical asymptotes, the x-intercepts, and the y-intercepts. So let's write down the factored form of the numerator and the denominator, one under the other, and let's see what happens. So I'm gonna write x minus 1 over here because I want to point out that these are going to be repeated factors. So if you want first of all, if you want the x-intercepts, those are going to be the zeros of the top. So that would be 3x plus 1 equals 0, which we already know that that's negative 1/3. So that's one of the x-intercepts. And you might be tempted to say that x minus 1 equals 0, which corresponds to x equals 1, is another intercept, but you would be wrong because that factor actually repeats. And so that corresponds to something we called a removable discontinuity or a hole. So a hole happens when x equals 1. That's when you have that repeated factor. And then the vertical asymptotes, to look for that, the vertical, these are, okay, sorry, misspelled that. So vertical asymptotes, those are the zeros of the bottom. So this would be x equals when the bottom is 0. But again, the factor that repeats you do not include because that corresponds to a whole or removable discontinuity. So the one that doesn't repeat on the bottom is x plus 1, so that corresponds to x equals -1. Okay, so when you write down the x-intercepts, I got the -1/3 for the x coordinate, but the y coordinate has to be 0. So any x-intercept always has y coordinate equals 0, and then x coordinate, we got that -1/3. And then for the vertical asymptote, I already know that that's x equals -1. And the whole occurs whenever I see that repeated factor at 1. Now, to find the y-intercept, this is where you have to plug in x equals 0. So if you plug in x equals 0, then all the terms that have x will disappear. And then I'm just going to get -1 divided by -1, which is just 1. So for the y-intercept, x is 0, and then y, as we found, is 1. So that would be 0, 1. So this is just plugging in 0 into the function, finding the y value. All right, so finally, let's talk about the horizontal asymptotes. So what's the story about that? What we want to do is compare the degree of the top and the degree of the bottom. So degree of the top, and let's say it's some number n, and the degree of the polynomial of the bottom, let's say that that's some number m. So if the degree of the top is larger than the bottom, then there is no horizontal asymptotes. There is something called slanted asymptote, but you don't have to know that part. So I'm not going to ask you. If the degree of the top is less than the degree of the bottom, then your horizontal asymptote is going to have equation y equals 0. And finally, if the two degrees are the same, then you take the coefficient, the leading term of the top, and divide it by the leading term of the bottom. So leading coefficient of the top divided by leading coefficient of the bottom. Okay, so now let's look at our polynomial. So we see that degree of the top is 2 because that's the highest power that we can see of x, and the degree of the bottom is also 2. And so here we have them the same. So we need to look at the leading coefficient. So 3x squared has a leading coefficient 3. And x squared has a leading coefficient 1. So we just divide one by the other, we would get 3 divided by 1. So this is where it's going to be y equal that. So this is going to be y equals 3 over 1, which is just 3. So that would be y equals 3. Okay, so now to match the graph, we want to match all the stuff that we've got so far. So first of all, the asymptotes. So there should be x equals -1. So we can see that that's this green line right here, right? That's looks like that's correct. And then y equals 3 is the horizontal asymptote. That's good. Now, the whole was supposed to occur at x equals 1. But here I clearly see that it's not correspond to x equals 1. That corresponds to x equals 0. So that's not good. So that's not the one. Let's take a look at this one. So we want x-intercept, by the way, of -1/3. That looks right. So that would be like where the graph intersects with the x-axis. X equals -1, the green line, that's a vertical asymptote. Y equals 3 is a horizontal, that's right. And the whole occurs at x equals 1. So far, I think everything is okay. And I also got my y-intercept was 0, 1. So I think it's this one right here, the second one. Now, just to verify over here, this does not look like the whole actually occurs at -1. That's not right. This one, the whole occurs at 1, yes, but to me, this looks like the incorrect horizontal asymptote because this is y equals -3 as opposed to y equals 3, because that's what we found. So I think that's what we're going to get there.